Hello aspirants, welcome back. So the last class we're talking about ISRO and its organizations. Now moving on to the next topic, that is the types of orbits. So the moment you're talking about the case of any particular satellite, the satellites are placed in the desired places, and those particular desired places we call them as the orbits. The satellites are placed in their well designated, well desired orbits for various purposes. So some of these particular satellites are intended to provide the information related to the changes that are taking place in seas and oceans. Nothing but the case of OceanSat satellites. There are some satellites which are intended to provide information related to the formation of the cyclones, related to the formation of the low pressure regions, at the same time the rainfall, right, the METSAT. The satellites which are intended to provide information related to the case of mapping of Earth, cartography satellites, Cartosat series. Right, at the same time the satellites which are meant for education, EduSat satellites. At the same time the case of the remote sensing satellites. The satellites which are intended to provide information related to the security of the nation, right, safeguarding, monitoring of the boundaries, territories. So RESAT satellites. At the same time, we're talking about the case of the communication satellites, the GSAT 7, GSAT 30, number of satellites. So all these particular satellites are placed in their well designated orbits using different types of launch vehicles. That may be a PSLV, that may be a GSLV, that may be SSLV or LVM3, could be any particular one that we are using as on today's date, right? So the moment you're talking about the case of these particular orbits, the orbits of these satellites, are basically two different types. So one particular orbit is equatorial orbit, and the other one is a polar orbit, equatorial as well as the case of polar orbit. Now these particular equatorial orbits, they are further divided. Into LEO, MEO, as well as the case of the GEO orbits, right? So what are these particular LEO, MEO and GEO? At the same time, what are these particular equatorial as well as the case of polar orbits? So first we'll be discussing about the case of equatorial orbits, right? The moment you're talking about the case of Earth, now assume that this is the case of Earth. At the same time, this is the equator of the Earth. At the same time, this is the North Pole and this is the South Pole of Earth. Now suppose that if at all we are having one particular orbit, so the orbit is above the equator in this particular way. At the same time, the orbit which is above the equator may be inclined like this. At the same time, the orbit which is above the equator, it may be inclined in this particular way. Now these particular orbits which are above the equator, and the moment you are saying above the equator, it means that the inclination of these orbits with respect to the equator will be around 0 degrees. At the same time, this particular orbit or this particular orbit, as we can see here, they are not exactly above the equator, but they are inclined at some angle with respect to equator. So what could be the maximum inclination? So here in this particular case, the maximum inclination of the orbits can be 20 degrees. So any particular orbit which is exactly above the equator, or any particular orbit which is inclined at a maximum angle of 20 degrees with respect to the equator, that particular orbit is known as equatorial orbit. That orbit is known as equatorial orbit. Now suppose that the orbits are something like this. So here in this case, this is the case of Earth. This is the case of Earth. At the same time, this is the North Pole of Earth and this is the South Pole of Earth. Right. If the orbit is in this particular way, if the orbit is exactly passing from North Pole to South Pole, or else if the orbit is inclined at some angle with respect to the poles, something like this. So here in this particular case, the orbit is exactly above the North Pole and South Pole, making an angle of 0 degrees with respect to equator. At the same time, this particular orbit and this particular orbit is inclined with respect to equator at a maximum angle of 20 degrees. Now such orbits, they are known as the polar orbits. Now the question that is common thing, what is common in these two things is that, so some of the orbits are exactly above the equator, making an angle of 0 degrees. And some of the orbits are exactly above the North Pole and the South Pole, making an angle of 0 degrees. And there are some orbits which are inclined at an angle of maximum 20 degrees with respect to equator. And even here in this particular case, there are some orbits which are inclined at a maximum angle of 20 degrees with respect to North Pole as well as the case of South Pole. So these orbits are known as polar orbits, and these orbits, they are known as equatorial orbits. At the same time, the moment you're talking about the case of the satellites which are placed in the equatorial as well as the case of polar orbits. So any satellite which is placed in the equatorial orbit will always move around the Earth from west to east. All these satellites which are placed in the equatorial orbits, that may be the LEO, that may be MEO or GEO. So any particular satellite which is placed in the equatorial orbits, they will be always moving around the Earth only from west to east. The reason, we all know that. We have already discussed about the reason in the last video. So these particular launch vehicles, whenever you are launching any particular launch vehicle, you make sure that it is launched from west to east, so that the surface velocity of Earth is being utilized, so that the fuel can be minimized to a very greater extent. At the same time, the direction, the relative motion of Earth can be utilized. The direction of motion of Earth, so that can be utilized. That is the reason why these particular satellites, or as the case of launch vehicles, they always move around the Earth only from west to east, but never from east to west. At the same time, the satellites which are placed in the polar orbits, they always move around the Earth passing from North Pole to South Pole. Any particular satellite which is placed, so here in this particular case, any particular satellite which is placed in these particular polar orbits will move around the Earth passing from North Pole to South Pole, and the satellites which are placed in the equator orbits, they always move only from west to east. And these particular equatorial orbits, they are further classified, they are further categorized into three different things. One is the case of Leo. Now the question is, what is this particular Leo? What is meant by Leo? Leo, in the sense you're talking about low Earth orbit. Leo is low Earth orbit. Now this particular Leo orbit, it is a type of equatorial orbit. It is a type of equatorial orbit. At the same time, the height of this particular orbit will be around 160 kilometers to 1000 kilometers. 160 kilometers to 1000 kilometers, that is the height of this particular Leo orbit. So in general, whenever we are placing any particular satellite, the satellites have to be placed. The satellites have to be placed at a minimum height of 121 kilometers. The satellites cannot be placed at a height less than 121 kilometers. The reason for that one, the moment you are placing any particular satellite at a height less than 120 kilometers, then in that particular case, the satellites will experience the gravity of Earth to a very greater extent. At the same time, the moment you are talking about the case of the weather balloons, so these particular weather balloons, they can reach to a height of around 40 kilometers. They can reach to a height of around 40 kilometers. At the same time, the moment you're talking about the case of the sounding rockets. So the moment you're talking about the case of sounding rockets, so in general, these particular sounding rockets are used for conducting, upper ionospheric studies. They are used for conducting upper ionospheric studies. Now the basic fundamental thing here, first we'll look into this one, then we'll go into the Leo orbit. So the moment you're talking about the case of Earth, this is the case of Earth, the troposphere, the stratosphere, mesosphere, ionosphere or thermosphere, and then finally exosphere. The first one is tropo, strato, meso, and then after that you have got the thermo or as the ionosphere, and then finally the exosphere. Now this particular troposphere, the troposphere, it extends up to 10 kilometers in the North Pole and the South Pole, and it extends up to 18 kilometers near the equator. The reason for that one, expansion. Because of high temperature near the equator, air undergoes expansion, as a result of which the troposphere extends up to 18 kilometers near the equator and only around 10 to 12 kilometers near the North Pole and the South Pole. At the same time, the stratosphere, it extends up to 50 kilometers, and then the mesosphere, it extends up to 80 kilometers. And the region of the Earth, which is above 100 kilometers. After this particular region, the space will commence, the space will begin after this particular region. And this particular height of 100 kilometers, that is what is known as the Karman line. The height of 100 kilometers, this particular height of 100 kilometers, right. So this particular height of 100 kilometers, that is what is known as the Karman line, the place from where the space will begin. So these particular sounding rockets, they are used for conducting the upper ionospheric studies. Now that is the main reason why these particular satellites, alright, they are placed at a height of not less than 120 kilometers. And the Leo orbit, this particular Leo orbit will start from a height of around 160 kilometers to 1000 kilometers. The LEO orbit extends from 160 kilometers to 1000 kilometers. At the same time, in this particular LEO orbit, the satellites which are meant for weather forecasting, the satellites which are used for weather forecasting, the satellites which are meant for forest management, the satellites which are meant for disaster management, the satellites which are meant for flood relief, right? All these particular satellites, they are placed in the LEO orbit. They are placed in the LEO orbit. Weather forecasting, weather analysis, forest management, disaster management, flood relief. At the same time, the case of even the case of your something like the case of your Earth studies also. For studying the Earth very, very closely, the changes that are taking place in the moisture levels, in the earth content, the soil content. So for all these particular cases, we place satellites in the LEO orbit at a height of around 160 kilometers to 1000 kilometers. And the satellites which are placed in the LEO orbit, they always move only from west to east. At the same time, the moment you are placing a particular satellite in the LEO orbit, so what will be the time gap, or else what will be the time delay? So you are introducing a satellite at a height of around 700 kilometers from Earth, 800 kilometers from Earth, 1000 kilometers from Earth. In that particular case, what will be the propagation delay? In that particular case, what will be the time delay? So the time delay in this particular case will be around 0.1 milliseconds. Sorry. So the moment talking about the case of time delay in case of LEO orbit, that will be around 10 milliseconds. So the moment you are calling it as 10 milliseconds, it means you're talking about 10 into 10 power minus 3, nothing but 10 power minus 2, or else you can even write 0.01 seconds. So whenever a satellite is introduced in the LEO orbit, the time delay, the propagation delay in receiving the signals will be around 0.01 seconds, which is highly negligible. At the same time, the moment you're talking about the case of the satellites in the LEO orbit, so these particular satellites which are placed in the LEO orbit, they just take around 90 minutes. The satellites which are placed in the LEO orbit, they just take 90 minutes to complete one orbit around the Earth. So in order to move one complete circle around the Earth, nothing but one orbit. So in order to complete one orbit around the Earth, the satellites which are placed in the LEO orbit, they just take how many time? They just take only 90 minutes. So all the satellites which are placed in the LEO orbit 160 kilometers to 1000 kilometers, they just take a time of around 90 minutes to complete one orbit around the Earth, which is very less. Now it is because of this particular reason, the communication satellites are never introduced in the LEO orbit. The reason for that one, if the satellite is moving around the Earth at a very greater speed, then in that particular case, receiving the signal at the same time sending the signal will be highly difficult. So in simple terms, the signal propagation and receiving will be very difficult, as a result of which we will not be in a position to communicate with the other person very comfortably and conveniently. That is the reason why communication satellites are never introduced in the LEO orbit. Communication satellites are never introduced in the LEO orbit. The simple reason, the time taken with the satellites in the LEO orbit is just 90 minutes to complete one orbit. At the same time, the other thing in case of LEO orbit is that The satellites which are placed in the LEO orbit, they have to be constantly replaced. Right? They have to be constantly replaced. So what is the meaning of this one? So the satellites which are placed in the LEO orbit, their lifetime is very, very less. Probably around 2 years or 3 years. Nothing beyond that one. Why? The speed with which the satellites move around the earth is very, very high, as a result of which they have to be constantly replaced. That is a major disadvantage in case of the LEO orbit. At the same time, the satellites which are placed in the LEO orbit, they experience one particular phenomena which is known as Doppler effect, Now the question that arises here, what is meant by this particular Doppler effect? Now basically this is one particular phenomena which we see in case of physics. So suppose that, I'll just give a simple example here. Suppose that a train is approaching. So the moment you are standing on a platform, and if the train is entering the platform, then in that particular case, the amount of sound received by us will be increasing. You are standing on the platform, the train is leaving the platform, then the amount of sound received by the ear will be decreasing. But in both the cases, the amount of sound which is generated by the train is not increasing, is not decreasing. We feel that the sound is decreasing. We feel that the sound is increasing. Why? With respect to distance. Which means that there is some apparent change in the intensity of sound. There is some apparent change in the frequency of the sound. You are just talking about apparent change. Apparent in the sense, the one which appears to be, the one which is not real, the one which is not true. That is what is known as apparent. Right. So the apparent change in the intensity of sound, in the frequency of sound, because of relative motion. Relative motion means both the objects moving like this, or both the objects moving like this, or else one object is moving in this way, one object is moving away. Or else one object is moving like this, other one is moving like this. Or else one is at rest, other one is approaching. Now this is what you call it as the relative motion. So it is because of the relative motion between the source and the observer, the sound, the intensity of sound, the frequency of sound, it either appears to increase or decrease, which is known as the Doppler effect. Now here in this particular case, why the Doppler effect is coming into picture? Why we are speaking about Doppler effect here? The reason for that one is Earth and the satellite both are moving continuously. But Earth is taking 23 hours, 56 minutes and 4 seconds to complete one rotation on its own axis. We know that Earth is moving on its own axis. We know that Earth is constantly moving around the sun. But for moving around the sun, it takes 365 days. But for completing one orbit on its own axis, it is taking 23 hours, 56 minutes and 4 seconds. But these artificial satellites, they are orbiting the Earth in just 90 minutes. So the speed of these particular artificial satellites is very much high when compared to the case of the rotation of Earth. That is the reason why the Doppler effect will come into picture, because both these objects are moving the same direction but with different velocities, as a result of which the relative motion comes into picture, and as a result of which the Doppler effect comes into picture. Right. So at the same time, the moment you're talking about the case of the LEO orbit. So in case of LEO orbit, the International Space Station, International Space Station is present in the LEO orbit. International Space Station is present in the LEO orbit at a height of 408 kilometers. Now the question is that who are the partners in case of the LEO orbit? Who are the partners in case of International Space Station? So in case of International Space Station, so NASA is a part of this one. NASA full form, National Aeronautics Space Administration. So it is NASA, and then Canadian Space Agency is a part of International Space Station. Then the Russian Space Agency Roscosmos is a part of this one. At the same time, JAXA, Japanese Aerospace Exploration Agency. At the same time, European Space Agency. These are the 5 members, 5 partners in case of International Space Station. And the recent updates related to this one. So last year you can say, or else you can even say in the year 2022, I suppose, right, after the Russia-Ukraine war broke out. So at that particular point of time, Russia has announced, Roscosmos has announced that they are going to exit from International Space Station in the year 2024. Right. So in the year 2022, when Russia-Ukraine war broke out, started, at that particular point of time, right. So at that particular point of time, Russia has announced that, Roscosmos has announced that they are going to exit from IWS in the year 2024. But in the last part of 2023, or as the early part of 2024, it was announced that Russia is going to continue, or else Roscosmos is going to continue in International Space Station at least till 2026. For another 2 years, Russia is going to be a part of this one. Roscosmos is going to be a part of IWS at least till 2026. At least till 2026. So the moment you're talking about the case of the orbits of these particular satellites. So first thing, what is an orbit? Orbit is a curved path that an object in space takes around another path due to gravity. So an orbit is a curved path that an object in space is taking around another object due to gravity. And these orbits, we have got 2 types. One is equatorial and the other one is the polar orbit. So the very first one, you talk about the case of the LEO orbit, nothing but the case of low Earth orbit. It is very much relatively close to the Earth's surface. So the height of this one is, it is normally at an altitude of less than 1000 kilometers, but could be as low as 160 kilometers, which means in simple terms 160 to 1000 kilometers, nothing less than 160, nothing more than 1000 kilometers. So this particular one, it can provide true global coverage and efficient use of the spectrum. So right, since it is very much close to the ground, it can provide a complete coverage. At the same time, the spectrum can be utilized to a very, very greater extent. At the same time, the propagation delay is just 10 milliseconds in this one. It is just 10 milliseconds, nothing but 0.01 seconds. That is the propagation delay in this. And what are the disadvantages in case of the LEO orbit? The mismatch of the orbital period of the satellite and Earth results in Doppler effect. So the satellite in the LEO orbit is just taking 90 minutes, but whereas Earth is taking 23 hours, 56 minutes and 4 seconds. So that is the reason why the orbital mismatch will take place, resulting in Doppler effect. It requires large number of satellites for whole coverage, and these particular satellites have to be constantly replaced because of their low lifetime, because of their less lifetime. These particular satellites, they have to be constantly replaced. Now this is the case of the low Earth orbit, LEO orbit. So here in this particular case, we can see that the North Pole and the South Pole, Earth is slightly tilted. It is tilted to an angle of around 23.5 degrees. That is the reason why you're calling this as equator. This is the equator, right? So here in this particular case, this is the equator. The equator is something like this, and this is the orbit. So this orbit is slightly inclined with respect to equator. The orbit is not exactly above the equator, but the orbit is slightly tilted with respect to equator. So such orbits which are at an angle of around 0 to 20 degrees at a height of around 160 to 1000 kilometers, we call them as the Leo orbits. Right. So this is about the case of the Leo orbits. In the next class, in the next video, we'll be discussing about the MEO as well as the case of the Geo orbits. Right. Thank you.